Good day. I am Arvin Enriquez, your subject teacher for probability and statistics. With this video lesson, we're going to discuss the topic identifying rejection region and hypothesis testing on the population mean. Our lesson objectives: at the end of this lesson, you are expected to first, identifies the appropriate rejection region for a given level of significance when A. The population variance is assumed to be known, and B. The population variance is assumed to be unknown, and C. The central limit theorem is to be used. Second, computes for the test statistic value, population mean. 3. Or third, draws the conclusion about the population mean based on the test statistic value and the rejection region. And fourth, solves problems involving tests of hypotheses on the population mean. For the introduction, in this video lesson, you will continue to learn about hypothesis testing. From our previous video lesson, we're done with formulating your null and alternative hypothesis and identifying what is the appropriate test statistics that we can use. You will learn the remaining steps in hypothesis testing with this video lesson. So these steps are identifying the appropriate rejection region for a given level of significance. So if there is a given value of alpha, so what will be the appropriate rejection region? So with the given condition, when the population variance is assumed to be known, the population variance is assumed to be unknown, and the central limit theorem is to be used. And the next step is to compute for the test statistics. So we're asked to compute for the C value or your T value. And from that value, we can have now your conclusion. So those computed C and T values that will serve as our basis in making our conclusion. If we're going to reject or not your null or your alternative hypothesis. Start with the example when the population variance is known. So for our example, if the variance is known, no, so the father of senior high school student is listing down the expenses he will incur when he sends his daughter to the university. At the university where he wants his daughter to study, he hears that the average tuition fee is at least 20,000 pesos per semester. So we need to take note of this, is at least 20,000 pesos per semester. He wants to do a test of hypothesis. Suppose from a simple random sample of 16 students, a sample mean of 19,750 was obtained. Further, the variable of interest, which is the tuition fee in the university, is said to be normally distributed with an assumed population variance equal to 160,000 pesos. Now, so there is a given value of level of significance here, which is your alpha, 5%, or simply if we convert this 5% to decimals, we just simply divide this 5% by 100. That's why it's 0.05. So for step number 1, it's about formulating the null and alternative hypothesis. So we simply use HO to represent your null hypothesis, and we simply use HA to represent your alternative hypothesis. So from the given condition or problem, no, for example, so our null hypothesis is that the average tuition fee in the targeted university is at least 20,000 pesos. So if we convert this statement to symbol, so we can arrive to your HO now is that your population mean is greater than or equal to 20,000 pesos. From our previous video lesson, we always said that your null hypothesis will show an equality between your population mean and your parameter. That's why there is an equal sign here. But now with respect to this at least, no, is at least 20,000 pesos, meaning to say that there is a possibility that the minimum amount that we can meet on the average tuition fee is equal to 20,000 pesos, and it can be greater than 20,000 pesos. That's why we use this symbol greater than or equal to 20,000 pesos. Because there is a keyword here is at least, meaning to say the minimum amount or the smallest amount that we can meet on the average tuition fee is 20,000 pesos. It cannot be less than 20,000 pesos because that will be the smallest amount that we can meet based on our assumption for our null hypothesis. It can be at least 20,000 pesos and it can be more than 20,000 pesos. Now, for your alternative hypothesis, we always said that your alternative hypothesis is totally opposite of your null hypothesis. So for this one, so the average tuition fee in the targeted university is less than 20,000 pesos because in your null hypothesis we assume that the average tuition fee is equal or greater than 20,000 pesos. Since we always said that your alternative hypothesis is totally opposite of your null hypothesis, then it should be less than 20,000 pesos in your alternative hypothesis. So once we convert this one to symbol, then we can arrive to this one that will be your HA, and your population mean is less than 20,000 pesos. So this will be your null and alternative hypothesis for our first example under your if the population variance is known. So for step number 2, it's about identify the test statistics to use. So what will be the best test statistics that we can use based on the given the values from our problem? So with the given level of significance and the distribution of the test statistics, state the decision rule and specify the rejection region. So in your step number 2, we're going to state the decision and specify the rejection region based on the chosen test statistics that we can choose now based on the given values on the problem. Now, what will be the appropriate test statistics to be used? So that will be the big questions now. Now, for your test statistic, with the known population variance, it was being mentioned in the problem, so we can use C-test as our test statistics to be used even though our number of samples is less than 30 or more than or equal to 30 samples. As long that your population variance is known, then we can simply use your C-test as your test statistics. And we will be using the C table as our critical or tabular value. So we can get your critical value or your C critical values from your C table based on the alpha value or the level of significance. So if that is one-tailed what will be the appropriate value for example, if your level of significance is 0.05, so what will be the appropriate critical value for that? If the test is two-tailed, then we need to divide your alpha by 2, and what will be the appropriate uh, critical values for that. So using your C table, we can identify now what will be your critical value to be compared to your computed value. Then your computed value should be greater than, no, or less than if we're dealing with, for example, left one tail test, left tail lang, left tail, we consider your left tail, then your computed value should be greater than the critical value for us to accept your null. If your critical value now is less than with your uh, I mean, if your computed value is less than with your critical value, then we're going to reject your null hypothesis. So that's how we use your critical value and your computed value using your formula, no? So if the population variance is unknown and the number of samples is less than 30, then we will be using t-test, or the test statistics follows the student's t-distribution with n minus 1 for your degrees of freedom. So we simply use this n minus 1 to get, for us to get the value of your degrees of freedom, which means the tabular value in the student's t-table will be used as critical or tabular value. Same thing with your C table. So from your T table, we can get your critical value or your tabular value based on your degrees of freedom and with respect to your level of significance also. In this given problem, so the appropriate test statistic to be used is C-test because your population variance is known. So we simply use this computed formula wherein your x bar is your sample mean minus your mu sub o, your hypothesized population mean, all over your population standard deviation sigma over your square root of n, or your sample size. So this will be the formula for us to compute for the value of c that we're going to compare for the critical value that we can get from your C table. So for the decision rule can be one of the following possibilities. Number one, reject the null hypothesis, HO. If your computed C is less than your negative C or negative critical value, otherwise we fail to reject your null hypothesis. If because if your negative C or your negative critical value is greater than your critical value now is less than to your computed value, then our computed value will fall on the non rejection region. That's why we fail to reject your null. We cannot reject your null if that's happened, no. For number two, reject the null hypothesis if your computed C is greater than your critical value. Otherwise, we fail to reject your HO. Same thing with your number one. For number three, reject null hypothesis HO if the absolute value of your computed C is greater than to your critical value with respect to your two-tailed test. Why is it two-tailed test? Because your alpha over 2 here will represent that your test statistics pertains to a two-tailed test. No? So we both both your left and your right side of your normal curve are to be considered. Otherwise, we fail to reject your HO. So these are the following scenarios, no, that we really need to reject your HO. So if your computed value is less than to your negative critical value, if your computed value is greater than to your positive critical value, or if the absolute value of the computed value is greater than to the critical value with respect to your two-tailed test. That's why it's C sub alpha over 2, because this will be your critical values for uh, both for your left and your right sides of your normal curve. So for the given problem, the first is the appropriate decision rule, because our HO use the symbol greater than or equal to as equality symbol. The decision rule must not overlap with the null hypothesis. So since the level of significance is 0.05 or 5%, so based on the C table, we can get the value of 1.645. If your alpha is 0.05, then the value of your C critical, or your critical C value is 1.645. If your alpha or your level of significance is 0.05, then your confidence interval is 95%. Now, the decision rule for the problem could be stated as reject HO if your C, or your computed C, is less than to your negative C critical value with respect to your level of significance, which is equal to 0.05. Based on the table, it is negative 1.645. Otherwise, we fail to reject your HO. So we need to satisfy this given condition here for us to reject your null hypothesis. So this test procedure is referred to as a one-tailed C test for the population mean when the population variance is known. So we considered only this side of the normal curve, so that will be a left tail test, no, one tail test, and we consider only your left tail test, your left tail of your normal curve, I mean. And the rejection region is illustrated as follows, meaning say if that is a left tail test, then only your left side of your normal curve will be considered. And there is only one rejection region in this problem, and that will be, or it will be, I mean, that will fall on the left side of your normal curve. So this part will be your rejection region. The non-shaded region here, so this will be your rejection region. Now, your critical value now is negative C sub alpha, which is 0.05. That will be equal to negative 1.645. So if we're going to plot this one, it will fall here, no? That's why I said from our previous video lesson that your critical value will serve as a boundary, no? Or the separation, or a line that will separate your rejection region to your non-rejection region. And this will serve as our basis for us to conclude whether we accept or not your null hypothesis. Now, if your computed C now will fall here or less than to your negative 1.645, you're going to reject your null. If your computed value will fall here or greater than your negative 1.645, then we're going to accept your null hypothesis. So that will be our conclusion for this one. So let's compute for your computed C value. So for step number 3, we're asked to compute the value of the test statistic. So from the given problem, these are the observations, data gathered. So first, there's the given value of your sample, which is your n, is equal to 16. Your population mean is equal to 20,000. So we assume that your population mean is 20,000. then your sample mean X bar is equal to 19,750, then your population variance is 160,000. For us to get the value of your population standard deviation, we just simply get the square root of this population variance, or it will be equal to square root of 1,600, 160,000, I mean, no? So whatever the value of square root of 160,000, so that will be your population standard deviation sigma. And the resulting value for that is 400. Now with the given values here, we just simply substitute the given values to the formula for your computed C. So we substitute your 19,750 as the value of your sample mean minus your 20,000 here as the population mean all over your 400. So that will be your population standard deviation all over square root of 16. That will be your sample size. So our resulting value for this one, or the more simplified one, is negative 250 over 100. Or if we divide and we arrive to an answer which is negative 2.5. So this will be the value now of your computed C to be compared to your critical value. And what will be our conclusion if we're going to compare your computed C, or computed value, I mean, to your critical value? So for step number 4, make a decision rule. So with the computed value of the test statistic equal to negative 2.5, the next step is to use decision rule. First, no? So we apply this decision rule, reject the null hypothesis if we satisfy this condition, that your computed C is less than to your negative critical value of C. Otherwise, we fail to reject your HO. Now, let's try to compare. So your computed C now is negative 2.5 and your critical value is negative 1.645. Why is that it is negative? Because it represents that your critical value will fall on the left side of your normal curve. That's why it's negative 1.645. From our previous discussion, no, whatever your area from your 0 to a positive 1.645 is the same area from your 0 to negative 1.645. So please do take note of that. So the negative sign here only represent that your critical value will fall on the negative part of the normal curve. That's why it's negative. So since negative 2.5 is less than negative 1.645 and we satisfy this given condition, then our decision is to reject the null hypothesis HO. So we're going to reject the null hypothesis HO because your computed C is less than to your critical C. Step number 5, state the conclusion. Lastly, as a consequence of the decision, conclusions are made which are in relation to the purpose of the test hypothesis. So based on the computed C and the critical value, if we compare this one, our decision is to reject your null hypothesis. So with the rejection of the null hypothesis, we will accept the alternative hypothesis. So our conclusion will be, therefore, no, the father can say that the average tuition fee in the university where he wants to his daughter to study is less than 20,000. So once we reject your null hypothesis, it's automatic that we're going to accept your alternative hypothesis. That's why our conclusion is that the average tuition fee in the university where he wants his daughter to study is less than 20,000 pesos. So let's move now with the example when the population variance is unknown. So what will be the most appropriate test statistics that we can use when the population variance is unknown? So the example for this, when the population variance is unknown. So the father of a senior high school student lists down the expenses he will occur when he sends his daughter to the university where he wants to her to study. He hypothesizes that the average tuition fee is at least 20,000 pesos per semester. He knows the variable of interest, which is the tuition fee, is measured at least in the interval scale or specifically in the ratio scale. He assumes that the variable of interest follows the normal distribution, but both populations mean and variance are unknown. So the father asks at random 25 students at the university about their tuition fee. So there is a 25 students here to be subjected, no? First semester, he is able to get an average of 20,000 uh, 50 pesos with a standard deviation of 500 pesos. Suppose the level of significance is set at 0.05, so that will be your level of significance or alpha. For step number 1, formulating the null and alternative hypothesis. So the appropriate null and alternative hypothesis remains the same as in the previous lesson, are stated as your HO or your null hypothesis. So the average tuition fee in this targeted university is at least 20,000 pesos. So we're going to use this is at least 20,000 pesos. In symbols, we convert this one as HO or your population mean now or your hypothesized population mean mu is greater than or equal to 20,000 pesos. Because based on the statement is at least 20,000 pesos, meaning say the minimum or the smallest amount that we can get, no, from the assumed statement, the average tuition fee is 20,000 pesos. So that will be the smallest amount that we can assume as a value of your average tuition fee. So it can be greater than 20,000 pesos and it can be equal to 20,000 pesos. Now, with your alternative hypothesis, we always said that your alternative hypothesis is totally opposite of your null hypothesis. Then now is the average tuition fee in the targeted university is less than 20,000 pesos. Because we assume in your null that your population mean is greater than or equal to 20,000 pesos. And your alternative now is totally opposite of this null hypothesis. Then your alternative hypothesis is symbol is your population mean is less than 20,000 pesos. For step number 2, identify the test statistics to use. So with a given level of significance and the distribution of test statistics, state the decision rule and specify the rejection region. So with the given values, no, what will be the appropriate, test statistics that we can use for this example? So our test statistic, so the population variance is unknown. So what will be the most appropriate test statistic now? And the number of samples is less than 30. Then we will be using t-test or the test statistics follows the student's t-distribution with n minus 1 degree of freedoms, no? Which means the tabular value in the student's t-table will be used as a critical value or a tabular value. No. First, what will be our indication that we're going to use your t? Your population variance is unknown. Second, the number of samples is less than 30. So these two statements are considered, no, before we come up with the idea that the most appropriate test statistics that we can use on this example is t-test. So we need to uh, satisfy, these two conditions. So in the given problem, the appropriate test statistic to be used is t-test since the population variance is unknown. So since the population variance is unknown, we can arrive that your t-test is the most appropriate test statistic. And if your n or your sample size is less than 30. Because we always apply your your t-test in a small sample size because the distribution is normal. Then now your t for your computed t here, t value that your sample mean is equal I mean your hypothesized population mean mu sub o. Then your s is your sample standard deviation and n is your sample size. So let's move forward with the decision that we can get from this test, a statistic. So our decision rule. So the decision rule can be one of the following possibilities. So we're going to reject the null hypothesis HO if your computed C is less than no with a negative critical T with respect to your n minus 1. So the value of your critical T will always be dependent no, on your alpha and your degree of freedom, your dHEP here. So that will be your n minus 1. Then for number 2, reject the null hypothesis if your critical value, I mean your computed t value is greater than to your critical value, which is n with respect to n minus 1. Otherwise, we fail to reject your HO. Reject the null hypothesis HO if the absolute value of your computed value of t is greater than to your critical value sub alpha over 2, which is with respect to your two-tailed test, and will be dependent to your degree of freedom, which is equal to n minus 1. So we need to satisfy this given condition no, for us to conclude that we're going to reject your null hypothesis. So if not, then we fail to reject your HO. So for the given problem, the first is the appropriate decision rule because our HO used is greater than or equal to as the equality symbol. The decision rule must not overlap with the null hypothesis. So since the level of significance is 0.05 or 5%, the confidence interval for this one is 95%. So we're going to use this confidence of interval or alpha in your table now for us to get the value of your critical value for t. So the critical value or the tabular value for the t table is 2.064 no with your alpha and with respect to your n minus 1 or your degree of freedom. The decision rule for the problem could be stated as reject HO if your computed C is less than to your critical value of T, which is negative 2.664. Otherwise, we fail to reject your HO. So we need to consider and we need to satisfy this given condition for us to reject your null hypothesis. This test procedure is referred to as a one-tailed t-test for the population mean when the population variance is unknown. So we only subject your left-tailed part of your normal curve, and the rejection region is illustrated as follows. So here, as you can see, the non-shaded region here is your rejection region. As you can see here, there is a non-shaded region here that will represent your rejection region. Now, once we plot your critical value with respect to your alpha or the given value of your alpha and the degree of freedom, no, which is n minus 1, that will be equal to negative 2.064. No? If we're going to plot this one, it will fall somewhere here, no, as you can see. So this value will serve as a separation between your rejection region and your non-rejection region. So for step number 3, compute the value of the test statistic. From the given problem, there are observations, data gathered, no? The first is your sample size, which is equal to 25. This is a small sample because 25 is less than 30. Then your degree of freedom is n minus 1. That will be 25 minus 1. That's why it's 24. Now your population mean is 20,000, your sample mean is 20,050, and your population standard deviation, I mean this not be a population standard deviation. This will be a sample standard deviation. So there is a typo here. So this will be a sample standard deviation which is equal to 500. So hence, the computed test statistic, no, we just simply substitute the given values to our given formula for the computed t, no. That will be x bar minus your hypothesized population mean all over your sample standard deviation s over square root of your sample size n. So we just simply substitute the given values, then we arrive from this one. Then as we simplify this one, that will be 50 over 100, then that will be equal to 0.5. Now, this negative sign here will only represent that the value or the side of a normal curve that we consider is the left side. That is a negative part of your normal curve. That's why there is a negative on your computed t, even if there is no negative in your formula. No, these negative values, as you can see in this negative t sub c is equal to negative 0.5. It only represents that the value or the critical value will fall on the negative part of your normal curve. So that's why there is a negative sign here. So for step number 4, make a decision rule. So with the computed value of the test statistic equal to negative 0.5, the next step is to use the decision rule. So we're going to reject the null hypothesis HO if your computed C is less than, no, with your negative critical T. So we're going to satisfy the given conditions here before we reject your null hypothesis. Otherwise, we fail to reject your HO. Now, let's compare your critical value when you computed T. Your computed T is negative 0.5 and your negative critical value, T critical value is negative 1.645. Since your computed T is greater than, no, with your negative uh, critical value, then our decision will be based on these values. So the rule dictates that our decision is not to reject or fail to reject the null hypothesis. So for step number 5, so state the conclusion. So lastly, as a consequence of the decision, conclusions are made which are in relation to the purpose of the test of the hypothesis. So right after we compare your critical value and your computed value, then from that will serve as our basis, no, for us to conclude whether we accept or not your null hypothesis. We will accept the null hypothesis because your computed value falls, no, on the non-critical region. We need to say we really need to accept your null and reject your alternative. So for our conclusion, therefore, no, so the father can say that the average tuition fee in the university where he wants his daughter to study is at least 20,000. So we just simply adopt and accept your null hypothesis because your computed value falls, no, on the non-critical region. So let's move now with the example, dealing with when the central limit theorem is used. So let's give an example for this one once we apply your central limit theorem. So for example here, as we apply your central limit theorem, so the father of senior high school student lists down the expenses he will incur when he sends his daughter to the university where he wanted her to study. He hypothesizes that the average tuition fee is at least 20,000 pesos per semester. He knows the variable of interest, which is the tuition fee, is measured at least in the interval scale or specifically in the ratio scale. He assumes that the variable of interest follows a distribution with a known population mean and variance. So the father asks at random 36 students at the university about their tuition fee for a semester. So we only subject 36 students for this experiment. So he is able to get an average of 20,200 pesos with a standard deviation of 400 pesos. Suppose the level of significance alpha is set as 0.05. Now, let's move forward with our step number 1 in formulating our null and alternative hypothesis. So for this step number 1, aligned to this example when the CLT is used. So step number 1, still formulating the null and alternative hypothesis. So the appropriate null and alternative hypothesis remain the same as the previous lesson and are stated as. So we simply use again these two hypotheses, no, your null and alternative hypothesis. So still the same with your first and second problem, no, because we really need to use three different scenarios, no, if the variance or the population variance is known, unknown, and once we apply your CFT, what will be the most appropriate uh, test statistics that we can use based on this situation. So your null hypothesis now still is at least 20,000 pesos. That's why your HO now or your mu is greater than or equal to 20,000 pesos, because the smallest amount that we can map on this average tuition fee is 20,000 pesos. It can be equal to 20,000 pesos or greater than 20,000 pesos. For the alternative hypothesis, since we assume that your population mean is greater than or equal to, then it's supposed to be the in your alternative hypothesis, it should be less than 20,000 pesos because your alternative is totally opposite of your null hypothesis. Then our alternative hypothesis now is your population mean is less than 20,000 pesos because this alternative hypothesis is totally opposite of your null hypothesis. For step number 2, identify the test statistic to use. So with a given level of significance and the distribution of the test statistics, state the decision rule and specify the rejection region. So what is the most appropriate test statistics when we apply your CLT? There is unknown distribution of a variable of interest as well as its population variance, but the sample size is large enough to invoke the CLT theorem. We simply use your CLT in a large population or sample, no? Because the CLT brought to us the concept that even your n or your sample size become larger and larger, still your distribution becomes normal. So the test statistic denoted as T sub C, which was used earlier, is still appropriate to use. Then this is test statistic is computed as T or computed T, which is equal to X bar minus your hypothesized population mean over sample standard deviation over square root of n, where X bar and S, no, are the sample mean and the sample standard deviation, respectively computed from a simple random sample of n observation, your hypothesized mean mu sub O, the value of the parameter, however, this time with the CLT theorem. We can assume that the test statistic follows the standard normal distribution, which means the tabular value in C table will be used as a critical or tabular value. With this decision rule can be one of the following uh, possibilities. In this case, we simply use your formula for your T, computed T, but again, your critical value will from the value, our critical value will be based on RC table, no, because it is a large sample. But again, there is a uh, unknown value of your population variance. That's why we apply your T. Then with the concept of CLT and your population standard deviation is unknown, and there's a given value of your sample standard deviation, then we simply apply the concept or the formula for this t, and we apply the critical value for your C table. So these are the things that we need to consider in dealing with this type of uh, example, no, when we apply your CLT. For the decision rule, so there are three situations, or we need to satisfy these three conditions. So we reject the null hypothesis HO if your computed T is less than to your critical value of C. Otherwise, we fail to reject HO. Then for number two, reject the null hypothesis HO if your computed T is greater than your critical value of C. Otherwise, we fail to reject your HO. And for the last or the third one, so we reject the null hypothesis HO if the absolute value of your computed T is greater than to your critical value with respect to a two-tailed test. Otherwise, we fail to reject HO. Actually, in this part, no, actually it's also a C value. Why? Because from our previous video lesson, we mentioned that if there is no given value of your population standard deviation, we simply use your sample standard deviation as a replacement for this sigma or this population standard deviation. That's why somehow this part or the computed values for t here is somehow the same, no, with your computed value of c. But because of the given condition, we actually use your the term t-test, but technically, it was the same because we mentioned from our previous video lesson that if there is no given value of your standard of population standard uh, deviation, then we simply use the sample standard deviation as a replacement or as a substitute, no, for these unknown values of your population standard deviation, sigma. So for the given problem, the first is the appropriate decision rule because RHO use this symbol as equality symbol, the greater than or equal to. So the decision rule must not overlap with the null hypothesis, still the same. So since the level of significance is 0.05, with the use of your C table, the computed, the tabular value or the critical value is equal to 1.645. So the decision rule for the problem could be stated as reject HO if your computed T is less than to the negative critical value with respect to left tilt of your normal curve, which is negative 1.645. So this negative sign represents that the critical value will fall, no, in the left side of your normal curve. That's why it's negative. Otherwise, we fail to reject your null hypothesis HO. So with this figure, so as we can see that we flat, no, your negative 1.645, that will be your critical value as a critical C value. So we simply use negative sign here to represent that the value will fall on the negative part of your normal curve. So this test procedure is referred to as a one-tailed t-test for the population mean when the population variance is unknown. It's a one-tailed t-test because we only consider your left side of your normal curve for this test statistic. So, and the rejection region illustrated as follows. For step number 3, so we're asked to compute the value of the test statistics. So from the given problem, these are, no, the observations data gathered. So from your sample size, which is 36, Your sample size here is equal to 36. That will be considered as a large sample because it's uh, greater than or equal to 30. So degrees of freedom n minus 1, that will be 36 minus 1, that will be equal to 35. Now for the population mean, and we use this 20,000 for your hypothesized population mean, mu, that will be equal to 20,000. And for the sample mean x bar, that will be 20,250. And for your population standard deviation s, which is 40. Now, we use population standard deviation here, but your symbol is s, no? Because if there is no given value for your population standard deviation, we simply use the sample standard deviation for as a replacement, no, for the value of your population standard deviation. Again, if there is no given value for your population standard deviation, then we simply use your sample standard deviation as a replacement for this population standard deviation. Hence, the computed test statistic is, so we just simply substitute the given values for a given formula. Here, actually, this T computed here is somehow equal to your C computed because there is a given condition that we mentioned, no, from our previous video lesson, that if there is no sigma, we simply use S or the sample standard deviation as a value of your population standard deviation sigma. Then we just simply substitute the given values here. Then for us to as a simplified more, that will be equal to 250 over 400 over 6, or that will be equal to 3.75. So we need to put negative here because we subject the left side of your normal curve in our test statistic. This negative represent that the value of your critical value falls on the negative part or left side of your normal curve. So for step number 4, make a decision rule. So with the computed value of the test statistic equal to 3.75, negative 3.75, the next step is to use the decision rule. So we just simply compare your computed T and your T critical. No, this critical value for this one will from the C value because your N is greater than 30. So we just simply get your critical value for the C table. Now, if we compare your computed and your critical value, the negative 3.75 is less than negative 1.645 in reality. That's why we need to reject your null hypothesis. Because the computed value falls on the rejection region. Meaning to say, if the computed value falls on the rejection region, then you need to reject your null and accept the alternative hypothesis. So for step number 5, state the conclusion. So lastly, as a consequence of the decision, conclusions are made which are in relation to the purpose of the test of hypothesis. With the rejection of the null hypothesis, we will accept the alternative hypothesis. Definitely, it is once we reject your null hypothesis, it's automatic that we need to accept your alternative hypothesis. Therefore, our conclusion now is the father can say that the average tuition fee in the university where he wanted his daughter to study is less than 20,000 pesos. So this statement is totally opposite of your null hypothesis. Since we reject your null, we should accept your alternative hypothesis. So I want you to take note of this. It's about your one-tailed and your two-tailed tests. So testing of hypothesis is an investigation of some prevailing belief against what the researcher believes. So there's a difference, between the prevailing belief and the researcher beliefs. If the researcher is investigating to check if what he or she believes is better than the prevailing belief. So there's a comparison between these two, for example, variables, then the test is known as one-tailed test. On the other hand, if the researcher is not interested in comparing the parameters, the test is called two-tailed test. So that these are things that we need to consider. If we wanted to, if we really want, to compare parameters, to or comparing the parameters, then we should deal with a one-tailed test. So if we're not interested, in comparing the parameters, then we should go to a two-tailed test. So that's how we decide, whether we use one-tailed or two-tailed test. It depends on what we wanted, as a researcher. If we want to compare the parameters, then go with two-tailed test. I if we don't want to compare parameters, then go with two-tailed test. If we want to compare parameters, then go with one-tailed test. So that's it. So that's how simple, uh, simple as it is before deciding whether we use one-tailed or two-tailed test. So the test is one-tailed when the inequality symbol being used for alternative hypothesis is less than or greater than. On our previous video lesson, I mentioned that uh, if, if we decide if that is a one-tailed or two-tailed, it depends on the symbol that we use on your alternative hypothesis. Simply, if we use a less than, then left the left-tailed the left side of the normal curve should be subjected, while if we decided to use the greater than symbol, then the right side of the normal curve should be subjected in the test of in testing the hypothesis, while it is a two-tailed test when the inequality symbol used is not equal to. Why? Because we don't know in reality if the computed value will fall before or after. That's why we use not equal to, because we're not the problem did not mention or not specific, if that is less than or greater than. So as a researcher, if we don't know if that is greater than or less than, then we should go with not equal to, and we use your two-tailed test. For your activity, so there's a given problem here. So your task now is to conduct a hypothesis test using 0.05. Some elements have been provided and answered. So please follow your step 1, 2, 3, 4, and 5 and decide whether you accept or not your null hypothesis and what will be your conclusion based on your test. I mean, from your computed value and your critical value or values. So thanks for watching. If you want to like, comment, share, and subscribe, so please do so. I'm Marvin Enriquez, your subject teacher for probability and statistics.